Hello, everyone, and welcome back. We will be starting the rest of our afternoon or evening session, depending on where you are around the world. I want to give an extra thank you once again to Mr. Mujica and Mr. Winterhalter for such a wonderful keynote presentation. We've had several questions come in since then. So it was very enlightening, and I think everyone really appreciated the discussion. One thing I want to just go over one more time, because we've had several people ask, is our housekeeping items. Again, the agenda is available on the forum site. So if you go to standardstechnologyforum.org, you will see it under the events page. The Zoom recordings that we're doing now, they are being recorded and they will be on the events page of the Standards Technology Forum once we're completed. And you may ask questions in the Q&A section of Zoom at the bottom of your page. If you have any questions or you have any issues, please feel free to reach out or chat me privately and we will share your questions. Okay, so with that, I am going to introduce our next session. Mr. Sebastian Kriegsmann will be moderating this session and will be leading us into a very interesting and dynamic conversation we're very excited about. So with that, I will pass it over to Sebastian.
Thank you, Lakshmi.
There's a bit of an echo.
Joe needs to mute. Joe needs to mute. Joe needs to mute.
Sebastian, if there's anyone else sitting with you, they may have to mute their microphone so that there's not tremendous feedback for you.
Check Joe Collins' laptop.
The audio.
How are we doing, Berlin?
Lakshmi, can you hear us?
I can hear you. Yes, there was a little bit of feedback. I think you fixed it. So you're good to go, Sebastian.
Hopefully, we were looking for the leak.
Oh.
I hope that fixed it. Okay, but now you can hear us fine?
Yes, very good.
Is it loud enough?
Yes, loud enough, okay. Loud and clear.
Okay. Sorry for this small accident. Thank you, Lakshmi. Thank you very much for a great effort to organize this forum and to guide us through the program. I now have the pleasure to kick off the first customer panel of the forum. Those of you who have also attended in the previous years know that we always try to represent the user's perspective as prominent and as diverse as possible. The central question has always been, which digital formats of standards help to support the increasingly digitized processes at the customers in the best possible way? Making standards more usable, that's what it's all about. But the question is how to understand what usable means in concrete terms. Well, by looking at the use scenarios and the specific use cases of our customers. Understanding them and deriving from these use cases which formats and which depth of information is required to fulfill the respective use case. So in this panel, we have 4 great guest speakers because we want to have a look at 4 different scenarios to see where there are converging requirements, but also where are differences. We are intentionally addressing use cases that can still be realized in the document-centric world, as well as use cases that purely require standards as data. You remember the Smart Standards Utility Model shown by Sergio in this presentation, originally developed by IAC. And this model describes different maturity level of digital standards. We assume that these maturity levels will overlap in time. In other words, they will exist in parallel. This poses one of the key challenges to the question of future viable business models, a question that will be further explored and discussed in the second panel of today's agenda. But now we will come to our presenters, and we will start with Peter Löwen. Peter is a product safety and compliance expert of John Deere, based in Mannheim, Germany. He also is member of various standardization committees at ISO and CEN on machine safety standards, roadway circulation of vehicles, and environmental requirements. Peter will introduce us to various requirements for standards data in the agricultural sector, which is moving toward digitally integrated value chains known as smart farming. The interesting part, to my opinion, is that Peter is making the link between his use cases and the utility model that you already mentioned. And this is exactly what we as standards organizations do when we identify use cases, when we assess them and qualify them in order to see when and how to implement them. And with this in mind, Peter, I would like to turn the floor over to you.
Thank you, Sebastian. Thank you for the opportunity to present today in this forum. I will share my screen, just a moment. Can you see my full page screen, please?
Yes, looks good.
Very good. Go to the front. Yes, I would like to start first. Oh, sorry, I just put down, doesn't disturb. So first of all, I would like to, I split the presentation into two parts. First of all, I would like to introduce my company a little bit, what all we do. Second is we go to the topic that I was asked to provide some our view on the smart standards. About the company, we were founded by a blacksmith named John Deere in 1837, which makes one of the oldest continuously operating companies in the United States. We are one of the, we are part of the 500 Fortune company. We are one of the largest company in the US, and actually we are Fortune 100 company. We are, although we are almost 2 centuries around, John Deere has a youthful outlook that we are eager to innovate and to lead the agriculture industry. We have about 70,000 employees over the world, and we are located in more than 70 countries over the world, in all continents except Antarctica. We are known, probably best known about the that we're building the iconic green and yellow tractors, as you can see on the slide. However, we have nearly 100 distinct lines of equipment, including, so we are leader in precision agriculture, like we are leader in combines, manufacture of combines. We own a Wirtgren company with all the 5 brands like Vogele. So this is a road equipment. We are industry leader in construction equipment, including, like you can see on this loader here. We are #1 in global forestry equipment. This is a forestry harvester. We build some of the most reliable and fuel-efficient engines in the world. In fact, John Deere engines are in demand not just for agriculture and construction equipment, but also for marine, forestry, and other equipment around the world. We are official PGA Tour supplier with the turf equipment. And we build 1 out of 3 lawn tractors which are sold in the US. This you can see that we just not build just a tractor, so we have a very wide range of products. And now I would like to tell you about about our operating model. In John Deere introduced a new strategy in 2020, so it's very recently, which is split into three organizational platforms. The first is the production systems, which are, this is how our customers get work done through a series of steps in their output, so that we can give the deep understanding of customer production systems and their needs and their costs that we can include. So that, for example, we are looking on, I will speak on later in detail about really one specific production system that we can supply him complete chain of technology, what he needs for his job. Technology stack is about, this is in the middle, is about technologies which enable to build the machines. This is today mostly represented by a common software development or hardware development, like controllers. And the software development is extremely expensive, so we try to commonality on for each platform to have a common software base. And the third one, the lifecycle solution. This is about how we can support customer during his lifetime. So it's about the customer support, maintenance of their machines, and so on. More detail in production, in the production system. The first and most important one is the production system, production and precision ag production system. This is divided into four production systems. First one is a corn and soy. This is sometimes called large grains. This is most typical for both Americas, North and South America, US, Brazil, Argentina. Small grains. This is represented by production of wheat, oats, and barley. This is as well as US, Canada, but also western part of Europe, Russia, all the CIS countries. Sugarcane typically represented by south of US and Brazil, and cotton as well, south of US, but also Turkey, for example. So a representative, maybe this brings us to development on special technologies, like, for example, here you can see ExactApply. This is special designed spray valves, which are mounted to each nozzle position, and using pulse width modulation that you can exactly and precisely measure the doses applied per hectare here. The second production system is called Small Ag and Turf, and this represents three systems: dairy and livestock. You can also call it hay and forage. So this is for the hay production. High value crops, it's vegetable and fruits, and then turf and compact utility, as you saw this turf equipment already. So representatives, this is a good example again of large technology. This is 9000 series forage harvester produced in Zweibrück in Germany. Construction forestry, I split it into three groups or three production systems: earth moving, road building, and forestry. This is representative, this smart grade motor grader, and example of forestry harvester. So legacy of innovation. So at John Deere, we think of ourselves as a disruptors who develop innovative products to meet our customer needs. So the biggest disruptive innovation of all we see and we foresee that it will be precision farming. So that this means that the next generation of smart agriculture technology and equipment. This is the combination of technology, equipment, services, and inside both customers' productivity and profitability. And this actually brings me into the today's topic, the smart standards, where I would like to provide more detail, some examples, some case studies, what we foresee that might be applicable for or in scope of smart standards. Nevertheless, before I go to the level 3 and 4, as you already indicated in some keynote, key speakers presentations, I would like to say that all the techniques or all the equipment you saw was just developed using the level 1 standards. So, and it's still the state of the art in our company, and I would say also state of the art of other ag companies. So how we use standards in daily work. So as a safety compliance engineer, one of our tasks is to contribute into the product specification. So when you plan a program, when you plan a new product, there is a document which summarize all the requirements, either from marketing, from customers, from product support, from customer support, but also all the regulatory and standard requirements which we need to fulfill for the particular market. So we working together on the product specification, where we have to review all the applicable standards and regulation. We are reviewing the country list for which markets is the product intended. And then, of course, during the development, we are all the time in contact with the design department or the product engineering department. After we conduct the internal verifications for testing and safety and compliance reviews, conducting sometimes for some products, if it's mostly on a roadway homologation, we need to conduct a third-party verification. So to organize this and all this. When the program is done, we need to all document, as this is a requirement, for example, from the CE requirement to complete technical construction files, all information documents when we apply for some type of approval to the third-party certificates. Certification, this is just collecting then at the end all the certificates together. There are certain formats for the certificates. And then we can release the program. And after that, once program is released to the start of production, the work is not done yet. So we still need to watch the program after 1 year after it's released, if it's still fulfilling as it should, fulfilling the requirements as it should. Beside all this, we have, especially on the first part of the 1 and 2 steps during the design, we also assist all the time to our product engineers about the correct interpretation of the regulatory requirements and the standard. So for that, we use the level 1, so open digital format, which is licensed to every engineer in our company. So everybody have to use own version of the own license of the standard. So we cannot share it, of course, and this is the I would say state of the art. How we work today. So regarding level 2, when I has the opportunity to study your plan level 1, 3, 4, 2, 3, 4, I saw, okay, there is a big potential for us if we get automatic update of these product specification documents, automatic update of the technical construction files, automatic update of the DOC documents, which includes, the versions of the standards, for example, and also automatic update of the verification criteria, which is actually written tasks for the test engineers, where we record the verification activities. Other example where I see a potential for this level 2 is, for example, automatic update of operators manuals, where you have standardized sections for safety decals, for safety messages. You know, this ISO 11684 is an example of safety symbols, for example, used on safety decals. So that could be automatically linked together, and the XML version of the standard can be used in such a way. Finally, finally, additional comment here for P engineers would be interesting to use this XML version as a automatic. So the requirements could be automatically transferred into the CAT tools with, for example, minimum safety distances can be kept, maximum dimension loads, minimum tank volumes, maximum residuals, and so on. So that could be in such a way transferred also to PE in the CAT tools, that they automatically will be not allowed to create or design across the boundaries which are set. Nevertheless, I also understand this even might not be the state of the art for our company. In some other industry, this is already state of the art, where are some business models or tools available for automatic recording, for example, technical construction files. But yeah, this is not really still spread in the industry. So the message here on these first two levels regarding to the use of the level 2 standards on daily basis would be a huge step for most ag technology companies already, if we come to that level. Let's go to the level 3 and 4 and the business cases. This is what you are most likely looking for from me to say today. Before I go to the business cases, I would like to, maybe I can highlight this down somewhere. What is the main motivation for these business cases? I work for the CropCloud platform, which deals mostly with pesticides application, so with the sprayers, field sprayers, and this is at this moment in very high level on the scope of the agenda, Green Deal agenda of the European Union, where the plan is reduce the dependency of the pesticides and antimicrobials, reduce excess of fertilization, and there are some concrete targets were set up by the authorities, by the government, EU Commission, where they want to reduce really the overall use of chemical pesticides by 50%, reduce of use of the more hazardous pesticides by 50%, and reduce fertilizer use by 20% at least. So as this may be linked to Mr. Winterhartel, as he said, this is the probably the unpleasant way how we need to, or we react with standards on the regulation. This is the case where we need to come with the new standards, where we are forced to basically set higher requirements first of all with the standards, but also develop new standards which are not yet there or not needed there. And this I will speak in a few seconds about that. Mm-hmm. Okay. So what is the Green Deal? So overall, you can see one big trend. So there is a demand for data. So for demand for application data. So the EU Commission and member state authorities. So it's not only, of course, the EU Commission, but it all comes from the member states, all the regulation and new requirements. So they would like to gather reliable information about total amount applied pesticides. They would like to ensure that only approved plant protection products, PPP, are applied in the right manner, in the right place, in the right dose. And they want to ensure that the spray application parameters are correctly used, so automatically adjusted according to approved operating conditions for each PPP. Here I need to say that the regulation is that every chemical product, so we're speaking about pesticides, must be approved first on the EU level for the active ingredients, and then it goes to the next round and it's approved on the member states level. And the member states, they approve the formulation. They also can approve the conditions under which the PPP can be applied. So that could be, for example, that you can use only certain range of the pressure, spray pressure in the nozzles. You can only use certain volume per hectare. You can use certain height of the nozzle above the ground to avoid, for example, the emissions into an environment. And yeah, so a deal for us, or for deal we understand for the farmer, is you can further use PPP, even you can further use the hazardous PPE, but you must apply them in a correct way and you must document it. Here we see our opportunity that we can make that requirement easier for farmer, so by avoiding the mistakes, so that when we provide kind of an automatic adjustment of the sprayer, we provide him legal certainty, first of all, so that he can be sure that he applied in correct way. And we did all the documentation which could be automated. So we're removing the administrative burden for him or for her. Potential of smart standards in ag machinery businesses. So that was the motivation first, and we'll come to the next topics. So here is, I try to, maybe this is obvious, that I try to make I set up a table here, which we differentiate on the requirements for first on construction requirements. You can understand it's just kind of a requirements for the iron, so for the which you cannot really change anyhow, and then the performance requirements, so which you can change easily by, let's say, setting different setting of the software, and you can easily change it on the way during the lifetime of the machine or during the usage of the machine. So, and this is the three main groups which we deal with. So we deal with general safety, we deal with the roadway requirements and environment. Regarding construction requirements, for example, rollover protection, the ROPS protection, safety distances, lighting, tires, tow eyes, or engine hardware, all the after treatment hardware, sensors, actuators, this you will not be able to change during the lifetime if you don't retrofit the machine. But what you can really change, or what we see a possibility to change, are the performance requirements. That's, for example, here, the complex electronics requirements on safety. So there you can set up differently the software parameters. Electromagnetic compatibility might probably change. Object recognition, so that is one big area. So for the autonomy, so that is applicable for road, but also for just farm field situations where it could be a little bit easier to achieve the required safety level than for autonomy on public roads. So that's why I split it here. And then a biggest area and biggest possibility for smart standards, level 3 or 4, is environmental. So engine emissions, emission of plant protection product. So this is the drift. Drift means that you apply the chemicals to non-target areas. So it's just drifted by the wind outside your target areas. You can recalibrate your sensors. I will bring the example of the slurry spreaders. GPS accuracy, you can also probably change that by a software. So this I highlight here red, the areas where we see the biggest potential for smart standards in agriculture sector. Example on field sprayers, just said, construction requirements, test methods, which are also part of the standards, also very hard to get that into the smart standards, and let's change them during the lifetime of the machine. And the group here on the right hand, so it's really the distribution performance. So this is example on distribution performance on sprayers. So where you can change the GNS, accuracy, spray pressure, boom height, steadiness, forward speed, nozzle type, you can change. Application net precision, weed detection sensors. All there we see a potential for the smart 3 or 4 level standards. Level 3, so this is about, as I said, about drift. You can see on the picture here what drift means. So drift means all this cloud of small droplets of the chemical mixture which should be applied just on the plant is drifted by the wind outside of the target area, and the regulatory foresee that this is of course not, this is not acceptable, and they would like to regulate the conditions under which you apply the chemicals, so that by reducing the pressure you can, and reducing the boom height, reducing the speed, you can also reduce this drift to really by 99%. So there is almost no drift. Here is an example of a project which we run together with the CropLife EU. This is a European Association of Chemical Produce or Agriculture Chemical Producers. And we are foreseeing kind of a cycle when the chemical is applied. So you have to first register, then you scan the label on the chemical before you or during you incorporate the chemical into the sprayer. Then based on the data which you scan in, the machine can download all the conditions under which the chemical can be applied. For example, no spray zones, all this, as I said, pressure, boom height, speed, and can automatically adjust the spray condition ongoing. So this is the step 3 and 4. So automatic application in the field. So by a standard and regulation defined the spray conditions for each approved product and culture plant combination will be transferred into the spray controller, and spray conditions will be automatically adjusted once PPP will be loaded to the sprayer tank. So this is one, I would say, great example where you can apply level 3 standards. This is a kind of a side note here. We were as an industry anticipating this regulatory requirement coming on us that authorities would like to monitor what the farmer is doing basically on the field. And we were already decided 1.5 years ago to create a standard which will standardize the parameters which make sense to record. So we can, as an industry, can decide which standards can be, which parameters make sense to be recorded, in which minimum accuracy we are able to record it, what is the data logging interval. So this is the frequency of the record. Doesn't make sense to record it every second or every minute. And also the location of the sensors which records this data. And then this is then task for other, let's say, working group to define the formats of the transferring the data to the clouds, either first of all to the owner clouds, because we are very cautious about the privacy of the data, that the farmer is the owner of the data every time, and he can or she can provide the data to the authority just on request in the case of inspection, for example, or to the other third party or farm management system, whatever. So this is an example of anticipation of such a regulation that we are going to forward and preparing as the industry a standard. Another example where you can level 3 is improving, for example, application map precision. So GNS, global position systems. So you can standardize the application maps, for example, which can be shared, can be standardized, the no spray zones, which can be shared among users. Example, minimum required GNS receiver accuracy. So you can also, let's say, online change the accuracy of the receiver, by just changing the software. And avoid, this will allow this is important, the application maps to reduce the overlap. So when you are, for example, turning, you are on the corner conditions here on the field, that you don't spray twice on one stop. And of course, you can improve the response times of the system at all. So this is again, this will be again example for the level 3 machine readable executable content. Regarding level 4, this is more, more complicated, of course. So machine learning comes into the play. And today, nowadays, I think there's a state of the art already on our tractors and our equipment. So you have self-driving equipment. So this is not autonomous driving. So you still have an operator in the cab, but using, let's say, a sensored camera visioning system or a row visioning system, the farmer nowadays doesn't have to really hold the steering wheel when he's driving across the field. So that's all automated. He can turn only on the headlamps. That means on the end of the field, he can interrupt the system and make a turn by himself. And then he just activates the system and drives again miles and miles in some regions straight away. But what I mentioned that, so we see and we are also preparing, programs. You can see on the right-hand side here where you have autonomous sprayer. So without any operator, without any cab there. And there I see potential for any, so this is general for every equipment, standardized safety software. So which, for example, for the object recognition, so that we can gather, let's say, the information about all the projects. And this is nowadays, every company do it by himself, by itself. So this is part of the know-how of the company. So there's a question about the know-how, how it could be shared, or IP, does it could be shared. But it would make great sense if we can get somehow standardized, let's say, object recognition software, and which can be shared on ISO level. Will save a cost, of course. Another example of level 4 standards would be, for example, for wheat. It's again object recognition. So in the case of the wheat, so nowadays we are able to recognize different type of wheat species in the field. We can recognize the wheat from the culture plant, and we can just spray it on the wheat itself. So we can hit the wheat with amazing accuracy. And it's also based on machine learning. So with every pass across the field, the system learns what kind of wheat is there, what is the level of infestation, and he learns about the new, let's say, shape of the wheat. So, and bring it into the database. So this is a question, can we have maybe in the future standardized shape recognition of the wheat? So again, a potential. However, again, here, I would say is an IP issue. Probably we will be conflicted with the IP issue. So know-how protection, because, some companies now invest in this, and then later years, you will get it standardized. Yeah. But maybe this is again, example of level 4 for level 4 standards. Finally, other case, this was about, I spoke about chemical application and spraying, and another case where is also linked to the environment is online determination of nutrient content of slurry. So slurry is a liquid, actually, liquid fertilizer, so coming from the animals. And nowadays there is an issue with over application of the slurry in European fields, but not only European fields, of course. And we are looking on the way how we can improve the situation. So there are projects like this related to near infrared sensor, which can determine exactly the natrium, potassium, and kalium content in a slurry, so NPK content in slurry, so the chemical compounds, and can, depending on, because the slurry is not homogeneous liquid, so depending on the content from each bulk in the tank, you can precisely control the application rate, that you don't over applicate these chemicals or these essential chemicals into the agriculture fields. So here the main potential, or why I'm mentioning that, the NIR sensors are sensors or working on a principle which is indirect principle. So it's very strongly based. The accuracy of that determination of the content is strongly based on calibration data, calibration curve for the of the sensor, which is again based on some samples from the region where the slurry is used. And this is usually, you can expect the calibration data, the calibration curve is updated maybe once or twice a year based on the standardized quality or standardized data about the quality of slurry. So again, here you can transform online or not online, you can transform and you can update the sensor from the factory to each sensor on the field. And there is, again, potential for the level 3, where this could be made in standardized manner, that a standard can be written for the standardization, for the calibration curves. I mentioned here level 3 and 4. It could be also level 4 because the sensors can, of course, send back the data, what they get it, and can be also maybe in the future self-learning system for. So that's why I mentioned here level 4. So here's just again example how complex is that nowadays, that you have a connection between tractors, tractor ECU. Between the implement ECU, you have many sensors on the machine, and this new NIR sensor, which is part of that machine, and this for that is foreseen the level 3 application of the standards. Yeah, some partners. NAL is the Dane partner for agricultural standards, and we are cooperating there to develop a new standard. It will be under an EN level, as you know, the need is currently on for the EU mostly. So we have again most environmental pressure, and that's why it's developed under EN. Yeah, with that, I would like to finish my presentation. Thank you very much for your attention.
Thank you, Peter. Very interesting presentation. Thank you very much. I think we're a little bit behind schedule. I would just like to.
Am I muted?
Sorry, I just wanted to say thank you very much, Peter. We will have some time for our discussion at the end. I just wanted to ask you one question coming up in the chat as well. Are you, apparently you're familiar with the levels of smart standards as we described them in level 2, 3, and 4. Do you have had any contact with standardization organizations looking at understanding the user needs and trying to translate these needs into the question how to build smart standards? For example, through any user group that we are organizing, that NEN is organizing, or anything like this?
Not yet, to be honest. It was pretty kind of a new information for us. However, I'm in contact with Jo Collins, and so she invited me to join one of the group, either at the end or the DIN group, which are dealing with this issue, with this topic. So maybe there we will have a chance to get into contact and discuss the cases, or participate maybe on one of the case studies which you would have.
Yeah, that would be great, perhaps, because the link between your use case and what is needed in terms of information that we should or could provide in the format of smart standards is to be assessed, of course, no? And this is what we do in these stakeholder groups, and very welcome if you're interested to join these. Doesn't matter if on the NEN Dutch side or the German side, we cooperate very closely. So thank you very much, Peter. And thank you. And with that, we come to our second speaker. Gerald Faschingbauer. Gerald is Managing Director of Dr. Schiller and Partner, Dynamic Construction Data. He heads the BIM business unit and is involved in national, European, and international standardization projects on the subject of BIM data exchange. Gerald will present an astonishing use case in a very specific area of application, that is the German construction sector. To make it clear, Gerald is not presenting the solution. Gerald, you will present a possible solution for a very specific customer demand. What makes it fascinating, though, really fascinating to my opinion, is the fact that this use case covers the whole value chain from content creation, content delivery, to content usage. And it works. And it works for many years now. And I think this is why this should inspire us. And with this, Gerald, I hand it over to you. The floor is yours. Thanks.
Thank you, Sebastian. Hello, everyone. Thank you, Sebastian, to have the opportunity to present here today. I will also share my screen, of course. Yes, I hope you see something. So here, this is my presentation. So ladies and gentlemen, I will present today our experiences based on the implementation of a smart standard, maybe a very special one. Sebastian already mentioned it. So we have a very special use case. I will show you some requirements for smart standards, maybe from the viewpoint of a software manufacturer in architecture, engineering, and construction. And maybe the concept is somehow adoptable for other application cases. First of all, a few words about our company. So we are a software company and also data provider. So we make data and knowledge bases, and we also make application software for architecture, engineering, and construction. And we also work together with DIN and the Joint Committee of Electronic Solutions in Construction on a special product called SDL Bau. This is both standard and software in one. We also work on solutions for cost estimations, for time estimations, and we are also linking applicable standards to data for civil engineering. But I will show you this in detail. What I will present today is a smart standard published by DIN since 1996. The name is SDL Bau. SDL Bau is a library of specification texts for standard construction works. And it enables users to dynamically build up standardized specification texts out of a non-restricted number of text fragments. I will show you that later on live. How is it done? It's a cooperation of 3 players. First of all, the JAEB. The JAEB is the Joint Committee on Information Technology in the Construction Industry. It's linked to our German Ministry of Building. There are around 700 experts of the economy, of the public sector, of product manufacturers who work on standardization texts. The work is done continuously. So this is not a standard who will maybe be ready sometime. It's a continuous work, and there are specification texts for, meanwhile, 77 trades. The DIN, the German Institute for Standardization, accompanies the work of the JAEB experts and the working groups and publishes the SDL Bau twice a year. So in April and in October, there are new versions of the standard and new versions of the texts. We, Dr. Schiller and Partner, or short DBD, we implement the database and the software system of the SDL Bau. So to make it more clear in which field we are operating, the domain is architecture, engineering, and construction. There for buildings, for heating, ventilating, air conditioning, plumbing, or also for infrastructure products. Our main objective is to enable users making bill of quantities for construction contracts. A bill of quantities is an important part of the construction project. It formulates the details and the terms and conditions in form of work items. So you have in such a bill of quantities, you have a lot of different work items formulating the terms and conditions of the project. And it is varying from each project to each other. It is used in tendering and in assignment. The standardization aspect we are focusing there is standardized specification texts. So the viewpoint is each contractor should understand the texts in the same way, and the text should fit to the current norms and standards in architecture, engineering, and construction. So the standardization context is these texts. The challenge here is that you can have billions of different text variations. So if you think about how many materials exist in the world, how you can build, or how many different traits you have in a construction project. You have walls, you have windows, you have floors, you have a lot of different traits in a project. So the challenge is how to handle billions of different text variations. This is done by combining the standardization and software. So the solution is the STL Bebau has model-based specification texts. You have no ready text, you have a system which is configuring the text using logical rules. And I think the best way is to show that live. So I hope it works all with the live presentation. I hope you see it still. Sebastian, can you see it?
Yes, we do, Gerhard.
Okay, thank you so much. So you have here the system, and here we have the 77 traits. Unfortunately, is in German, so I'm sorry, not everybody maybe can understand it, but I will say a few words about it. So you have here a lot of standardization, a specification text. Sorry. You can go through this folder structure, and I will go to show it in the example of a window. So I will describe a window made of wood. So, and now here I get a specification text, but this text is not a static text. This text is standardized dynamically. So I can here choose, based on these properties, I can choose other options. So I can choose, instead of this, I can choose another option, another property, and the text will also change. So I will get another text if I change here anything. I can change also things within the text. So I can change here in another option. I can make maybe this door transparent. I can also bring here other options. So I can, for instance, so I can here choose another material, and you see here also some things are gray. So you have here also an internal logic which avoids combinations which are not possible. So with that, you can configure millions of different texts. Of course, these texts have to follow the actual norms and standard. And you see here also this DIN sign. If you go here on this DIN sign, you see the relevant norms according to this specification text. So you have here a context-sensitive filter for applicable norms and standards, which are linked here with this system. And you can here also go into some parts of the standards which are appropriate maybe for any problem. These things are also directly linked somehow in the text. So if I have the question, what is this? What is this Beanspruchungsgruppe? What is meant here with these things? I look in the special norm and I see the definition of this property. So this helps the user, and here is also again the viewpoint of the user is the important. That is that I think what Christoph Winterhalter said in his speech today. The user is the important thing. This helps the user with the standard to look in the standard and make his specification text in the right manner. So we'll go back here into my presentation. This way of configuring texts is used by about 30,000 users of the STLB BAU who use that for public and also private projects. The users specify the text, and the text will be computed just in time. So not the texts are in the storage, the rules and the configuration rules and the basic content is stored in the database, and the rest will be live. That I have also already shown. The norms and standards are directly linked to the text and can be used in the context of the work directly in the process. So the question is, if this is a digital standard, how can you use that? And the use of this standard will, of course, be done by software application. So this standard is, of course, a software for itself, but it is directly to be integrated in other software applications. So if you have a software application for tendering, awarding, invoicing, and so on, this software application can access this standard STLB BAU via an API. You have seen the user interface. It's the same in each software application. So if this is a software application, this user interface is directly integrated in the other software application, and the data will be communicated via an API. So each software application can integrate this solution and therewith use the standardized text. And the big advantage of this is not every software have to focus on the logical restrictions within the data. The specification texts will be provided as a kind of service, and software applications can use this service. This is meanwhile also used for building information modeling. Herewith you have integrated systems where you have models of a building, and maybe it's not good to talk so much theoretical things. I will here show also a few examples. So if you, for instance, have a software where you make a model of a building, then you can specify the model elements. In the end, you have also, again, in a lot of different software products, you have, again, a link to the STLB BAU. You get here the ready-to-use texts for specification, and therewith you can make bill of quantities also in different software solutions. So the standard itself is a kind of software, you see it here, and it is directly connected and integrated in another software. And also the access to the DIN norms is in each case is possible. So the DIN norms are directly linked to the standard. I don't know how many applications already did integrate it, but it is a lot. So what is here from our point of view, the big change? The big change, not only for other example, but also maybe for a number of additional examples will be that we come from readable norms and standards to executable norms and standards. And the addition we have to do is you need software components as a part of the standard. In this case of FSDLB Bau, this is done with 3 different competences which are here combined. We have the standardization competence of DIN. We have also the domain competence, and we have IT competence. And what you see here, each partner involved in this project has to have a little of the competences of the other, of course. So we have to know a little bit about standardization. And we have also to know a little bit about the construction domain, of course. The same here. DIN has of course standardization competence, but also needs a little of domain competence and also some part of IT competence, the same for the GIEB. So in this combination, if you can combine standardization competence, IT competence, and domain competence, then I think that smart standards will be possible in a lot of fields, not only in, let's say, niches like we have it here, but in a broad field. And with these words, I thank you very much for your attention. I hope I have held my time. And if you have questions, of course, I would be very happy about it. Thank you.
Thank you, Gerard. Yes, you have absolutely held your time. I have a lot of questions. I'm looking a little bit at the chat, whether we have questions. Perhaps, Gerard, perhaps you could give us a little bit more ideas on how the standardization process differs. So what exactly is, or what is being done in the standardization process in order to provide the information that you can then use in the software?
So the standardization process is that you already have seen there are around 700 experts in 77 groups. And these 77 groups are DIN is managing these groups together with the GIEB. So in each group are between 5 and 20 people who are continuously studying the norms, because the specification texts have to follow, of course, the actual norms and standards. So the norms and standards will be reviewed if they are new, and there will be decided, are there some needs that we have to change the specification texts. Then the groups with the experts, with the domain experts, sit together and decide, okay, how should a specification text for this problem or for this work item should look like. So they decide based on the norm in combination with DIN, how should the text be? If this is decided, DIN takes the minutes out of these discussions. So this is, let's say, sometimes a thicker, not only paper, now it's digital, but we have kind of protocol, and this will then be implemented in the software here with us with DBD. So we implement it in the software, and then we have test versions. So before the new STL-BBau version will be released, the working groups get it back and see if everything works fine, if everything is correct. Then maybe we do some corrections. And after that, the new version of STL-BBau will be distributed. This is then twice a year. And it is also a never-ending story, because also the construction norms continuously are changing. So in the last 20 years, each year maybe about 50 norms have been newly implemented in the STL-BBau. So it's a continuous work all over the time. And it's logical, but it's, let's say, it's a very special case. I think this holds not for every topic, but in our field it is like this. And the interesting thing is the cooperation, I think, between the different competences.
And there was a question regarding the joint committee. I get that this means the GAEB, the GAEB. Do they reach out to the original committee that drafts the standards to confirm the use? Is there kind of a feedback link back to the standards committee to confirm how the content is used in the software corresponds to the intention of the standard itself?
Sebastian, I'm sorry, I didn't understand.
Yeah, I'm not completely sure if I understood right the question, but the question was, Gerald, to be clear, does the joint committee, I guess it's the GAEB, reach out to the original committees that draft standards to confirm use? So I guess this is the DIN committee, for example, publishing a standard, and then the GAEB is accessing this standard in order to make the link to the data model that you just presented, right?
Yes. So the GAEB groups are accompanied from DIN. So DIN brings the new norms, and the working group reviews that and decides about the text. And there is also you also, I think, asked about feedback. There is also feedback in the end from the user, because there is also a feedback system integrated. So if there are needs for the text, or if something is let's say, open, or if there are some questions, the users have the possibility to ask directly the working groups via integrated system.
Okay. Thank you, Gerald. Yeah, I just thought that we will hold some questions to the end, to the final discussion. Gerald, with this, thank you very much again. And,
thank you also.
We'll stay online, I think, and we go to our next presenter. It is John Schmelzle. John is with the division at Lakehurst, New Jersey of the US Navy, focused on air-related initiatives known as NAVAIR. He is exploring ways to incorporate additive manufacturing, such as 3D printing of parts as replacement for broken or disabled components, for example. This discipline is still quite new, and the industry is working with several SDOs and NSBs like ASTM and ISO to develop these standards, certifications, and trainings. And in this presentation, John, you will provide us some insights on the way you work with requirements, data-based or model-based, and how to transfer, for example, 3D models into the standard format that we use today. John, we're very interested to learn more about this, and I hand the floor over to you.
All right, thank you. I assume everybody can hear me okay. I'm going to try to share my screen here, if that's all right. And please let me know if everybody can see the screen share.
Yes, we do.
Fantastic, thank you so much. So, like you said, I am from NAVAIR, Naval Air Systems Command, and I am an engineer who works with the additive manufacturing. And I'm going to talk a little bit about additive manufacturing and the standards and our technical data packages and 3D, how we implemented a 3D PDF solution, and how we use standards, and what our vision is moving forward. So real quick, Naval Air Warfare Center Lakehurst, we're known for two things. One is what's called ALRAE, Aircraft Launch and Recovery Gear. These are the catapults on the aircraft carriers, and it's the resting gear and everything that's required to launch and recover aircraft on an aircraft carrier. The other thing we do is support equipment. That's all the equipment to repair, maintain, and test the aircraft. So basically, I mean, we're responsible for when the aircraft, to land the aircraft on the carrier, fix the aircraft, and get it operational again, and have it take off again so they can perform their mission. So that is what the Lakehurst mission is. One reason why it applies to additive manufacturing is because we are looking to deploy 3D printers out to the fleet, onto aircraft carriers, and we're classifying this equipment as, you know, repair equipment. So we're going to use this equipment to make aircraft parts on site to help in our mission of keeping these aircraft flying. So real quick, what is additive manufacturing? I thought I would discuss this quickly. And I mean, it's a process that manufacturing process that uses a digital 3D model to additively join material in a layer by layer process to form a final part. And that's the fundamental definition has been put out by ASTM, that standard organization. And it's a definition that's been pretty much accepted around the world. There are 7 types. There's seat lamination, vat polymerization, material jetting, binder jetting, material extrusion, power bed fusion, directed energy deposition. So all this 3D printing that fall into these 3 different types, these 7 different types, and they all have their own unique capabilities and advantages, disadvantages. And real quick, just to discuss advantages of additive manufacturing. I know a lot of people hear a lot about 3D printing in the news, and why do we use 3D printing? 3D printing provides certain capabilities that we never had before. One, you can 3D print very unique organic shapes. In traditional manufacturing, we always try to manufacture parts based on, to design parts based on that manufacturing process we're going to use. And that puts a lot of constraints on the engineer, the design engineer, because they have to, you know, take into account that somebody has to make this. In additive manufacturing, you take away a lot of those constraints. And I always like to say the one constraint with additive manufacturing that we place on those design engineers is it's the limit of their imagination. You can print so many different things. So it really frees the engineer to print different things. And another thing additive manufacturing does is it provides unprecedented capability to manufacture parts on site, on demand, something that we never really had before. So it's these types of things that really make the Navy have an interest in additive manufacturing. One of the things that I was asked to talk about was the ANSI gap analysis that was done. America Makes, which is an additive manufacturing organization, and ANSI, which is standard. They're more of a standard type of oversight organization. They put together this collaborative meeting with industry, an initiative, I should call it, to look at all the standards that exist right now, and then look at all the standards that additive manufacturing requires for it to be a truly, you know, full process, and identify what those gaps were. From my perspective, I mean, I not only participated in this, I actually led one of the subcommittees for design of additive manufacturing. And we looked at all those all those standards and said, okay, what do we need from these standard organizations to get us to the point where we can implement additive manufacturing worldwide. So that was a big initiative, and a lot of good has come out of that. A lot of standards have been updated, a lot of initiatives to make new standards have pushed forward. So we are getting there, I guess is where I'm going with that. Another thing they wanted me to talk about was, well, kind of our own, some of our own standard initiatives. I mean, we have what we call our triage process, where the fleet comes in and they request to 3D print a part. And then we go through our process of looking at whether or not this part would really qualify. And, you know, we look at, you know, the stock supply, the cost, failure data. I mean, why can't the current system handle this? Feasibility of printing this, what's the criticality of the part, airworthiness. One of the things that comes out of this is, you know, a lot of things come out of this is, can we make it? You know, should we make it? I mean, one of the things is this AM part classification level. We classify all our AM parts based on the consequence of failure of that part. And from that consequence of failure, we now look at all our standards, our technical data packages, how we qualify vendors, and that will all be unique based on that, that classification level. So that was something that we did in NavAir, that we had a kind of a discussion with industry. Part classification, here you can see it. I'm actually leading this committee because there was a lot of interest in industry about what NavAir did. I mean, other DoD agencies kind of did similar things, and a lot of our industry partners also kind of did the same concept. And the idea of classifying these parts, putting together a standard of where these parts would lay based on their consequence of failure. And then based on where those parts fall, that would then dictate how other standards would handle them, if that makes sense. So you could have like an NDI standard that might differ, you know, call out the part classification. And if it's a class 4 part, require certain things, where if it's a class 2 part, require other things. And I'll discuss this a little bit when I talk about our technical data packages, which I'm actually going to get into now. So a technical data package, that's a military term, but basically it's the authoritative technical description of an item. This is really your drawing package. And we really did a lot at Lakehurst regarding technical data packages, not just for additive manufacturing, but for a model-based initiative. So, I mean, this is really AM and traditional manufacturing where we moved into this, but it really does apply a lot to AM because AM really requires that model. You need the model to print. So without it, you're nowhere. So we actually require a model-based definition package, technical data package for all our additive manufacturing parts. What does a technical data package include? It includes your models, your drawings, associated lists, standards, quality assurance provisions. It also includes critical manufacturing processes, which I'm going to talk about a little in a little bit, because you look at this box here, and this comes out of MIL Standard 31000. It talks about product design. It doesn't really talk about these manufacturing information, but that's actually a manufacturing document that we include into the technical data package. It's kind of an example of a structure that we might have for a technical data package. PDDS, just to elaborate what that is, it's a product definition data set. It's basically a 3D drawing, and I'm going to talk about that in a little bit more detail shortly. But you'd have different PDDSs, and these different 3D drawings would call out different standards. So you basically have a package of documents that make up this technical data package. This additive manufacturing process description, this is a new document that we created. This is where we talk about not just what the final product should look like, but how to make it. And this really is going to tie back to that part classification, because we're only going to tell you how to make it if it's really critical that we tell you how to make it. Ideally, I would just tell you what the end item is and not tell the manufacturer how to do the job, his job, because I don't want to do that. But at this point, based on the technical maturity of additive manufacturing, we feel in some instances, if parts are really critical, that we really need to put that how to make it also in the technical data package. So looking at how would, and we look at the technical data package and we look at part classification, and here we have that qualification level, which is that part classification level, and it's 4 levels, will determine how we put together this technical data package. Whether we have this process document, which is required in level 3 and level 4. In a level 1 or level 2, we might have it, but it's not required. It's basically a document to help our, organic fleet people make the part, but it's not something we would ever put on a contract. So this is an example of how one way we use that part classification in a downstream process, in our technical data package process. Another way we use it is how we qualify vendors. A vendor might be qualified to make a level 4 part, or they might be qualified just to make level 1 and 2 parts, right? Because based on that part, our vendor qualification goes back to that standard that we implemented. So I'm going to talk a little bit about this model-based definition, 3D PDF, product definition data set that we call it, which is the 3D drawing. Why did we go to a 3D PDF? And this was a debate. I wrote a paper about this. It's a neutral file format. We want everything to be neutral. We don't want to be tied to any specific CAD manufacturer. I mean, I know it might be unrealistic to think a CAD manufacturer might go out of business, but I mean, that's certainly possible, which would lead us, we'd have fundamental problems. One CAD manufacturer did actually not make their software downward compatible. So if you actually got up to version 4, you were okay. But then when you went to version 5, well, you no longer could look at anything used in version 4. So we don't want to be tied to a proprietary format on our technical data. So we love the idea of 3D PDF being a neutral format. A lot of people think PDF is Adobe format. Not true. Used to be an Adobe format. It's actually PDF is made to an ISO standard now. We make our technical data packages in accordance with WAI 14.41. That's a standard that is used, governs product definition data sets. Again, 3D drawings. PDF is readily readable. I mean, almost everybody has an Adobe reader on their computer. It's compatible with Gedmix. And another thing we do is, nice thing about PDF, you can embed things into it. So we embed a step file, which is compatible with our computer-aided manufacturing processes. And also provides us long-term archiving capability, which is very important for us. So this is a look real quick about what the 3D PDF looks like. I'm going to actually switch my screen here so we can look into, I'm going to move this over here. So this is the actual 3D PDF of a hydraulic manifold. This is a relatively simple item. We have far more complex items, but this is what I have that's approved for public release, which obviously I need for this. But it basically looks similar to what you would see in a drawing. But when we go to the second sheet here, and we see a model, and there's a model that I can turn around and look at, has different views, and we have sections in here, and you can see the sections with all the dimensions. One of the things with these dimensions, and like I said, I can twirl it, I can make cuts in it. One of the things, all these dimensions, they're semantic. So when I take this part, I can input this part directly into our computer-aided manufacturing processes, they can manufacture this part. I can take this part and put it onto a CMM machine, a coordinate measuring machine, and the machine will interpret all these dimensions, all these tolerances, and be able to inspect the part seamlessly. The user doesn't have to input any of the data. Matter of fact, the inspection process, the program for the inspection process can be fully automated. So we don't need, we can kind of divorce ourselves of a lot of this labor because all this information is semantic. It's all embedded into the 3D PDF. There's a lot of other information embedded into the 3D PDF. So, I mean, that is all semantic. So a lot of this, a lot of that information, you know, all the specifications, the feedstock requirements, and a lot of this other, it's part classification. It's all semantically embedded into this file. So this is basically, you know, this is a full model-based definition approach to our parts, and this is what we're really looking at going to. You can see in here, these are the embedded documents. It's a step file in here. That step file is something that can be freely imported. Machine comparison report. That basically is a comparison between the step file and what we're showing visually here in the PDF. There is a translation. So in this report, we govern that the translation must be within 1/10 of the smallest tolerance of the drawing. That comes from the gauge spec. So you have all this information, and again, this is like that smart idea of, you know, having all this semantic information available to the machinist, where they can all be pulled in. They don't have to do all this programming themselves. Moving forward, so 3D PDF was did want me to discuss what we need from the standards. We work with a lot of the standards organizations. It's something that we truly want to leverage, so we do that. But many in additive manufacturing, because it's so new, a lot of the organizations they start off with guidance documents. I don't know how many times I've seen this, where they think they're going to do a standard and then decide, well, we'll start out, we'll release a guidance document. Guidance documents do very little for me. I mean, it's great for a manufacturer who may want to look at best processes and they can use that to help, but I need something I can put on a contract, right? So I have to, I need the shalls, not something a manufacturer should do, but he shall do it, and he needs to meet that requirement. We need to fill in the gaps from that ANSYS analysis, that gap analysis. That's another thing that NAVAIR needs. I mean, we help to put together that gap analysis along with the rest of industry. And one of the things I will say, NAVAIR, we work with these standard organizations to produce these documents, and we truly, we do truly leverage these documents. We do develop our own specifications. Ideally, this would be more interim. We don't want to have our own specifications. It doesn't make sense for people to have to make their processes governance, you know, for us. However, until the standard organizations come up with that complete solution, we have done this for an interim solution. We would prefer to use industry standards. We're definitely how we want to proceed. Interim solutions are often based on released guidance. We look at those guidance documents, which ultimately, you know, many times we participated in creating, but we take that guidance and we turn those shoulds into shalls. And something that we can really sink our teeth into. Part classification is a good example of a NAVAIR standard that we made. We made this standard, and now we're moving it into an industry standard. So again, we want everybody. We don't want parts to be classified, you know, differently for everybody across the industry. We want everybody to be marching to one drum. So although we had input, the new standard is not going to be what NavAir had. It's we're gonna have to adopt to what the industry wide wanted. But and we're good with that. What I mean, from our standpoint, the key factor is that we have an industry-wide standard that we can all agree to is the best way, moving forward. So when we classify a part as a Class 3 part, GE is also, classifying their parts as same part, as the Air Force, the Army, Raytheon, we all march to the same drum. So I'm going to close real quick with where our vision is. As I said before, we are deploying printers to the fleet. We are going to populate the aircraft carriers with these printers. The idea is we can ship electrons, not parts, right? So we can ship that digital model, and they can make the part on site. From an inventory perspective, it's great. From a logistics perspective, it's great. The carriers are the ultimate version of a strained supply line. You have a ship out in the middle of the Pacific. They need a part. They can't go across the street to Walmart or anything. So I mean, this is an ideal advantage for us to implement this technology. We want to leverage our industrial base. We don't necessarily want everything to be, we're not looking to take over manufacturing. Only in some instances, we want to qualify our AM vendors. I mean, most of our manufacturing is done on land sites. So we want to leverage those vendors. We want to qualify them based on those part classifications. And the other thing, we want to continue the research. We do a lot of research into additive manufacturing. Ultimately, when we want to, increase that technical readiness level of the AM equipment, such that it will more meet our needs. So that's my brief, Sebastian. And
thank you, Don. Thank you very much. I think we have quite a lot of questions. We will address some of these at the end in our joint discussion. Perhaps just a few. Could you give us an idea how you extract the information to build the 3D models and enrich them semantically? Which technology do you use in order to do this?
I mean, what we're doing at Lakehurst is we're using a program called PTC Parametric Technology Corporation. Creo is the name of the program for our computer-aided design. We have what's called a start part, where the engineer starts with that part that has a lot of this embedded information. And then we use a program called Anarch to do the conversion into the 3D PDF. The template, the 3D PDF template, was something that was created at Lakehurst. So basically, the Anarch program takes that Creo parametric model and puts it onto that template for us. And then we use a software from ITI called CAD-IQ to do a lot of that validation to make sure the process has gone through and there are no errors.
Okay. And do you have the possibility to automatically or programmatically verify the measurements of the 3D drawings of the 3D models?
Well, yeah, that's what we use the CAD-IQ to do that validation, to make sure if you're talking about to validate that the 3D drawing is correct, yes, that's what we use the CAD-IQ for. To validate the part is correct and meets the drawing, yes, they can. Those measurements that are on that 3D drawing will go into the CMM machine, the coordinate measurement machine, and validate.
Very interesting. Thank you, John. Thank you. Yeah, our last but not least speaker is Ralf Sporer. Actually, Ralf, it's no coincidence that you closed this panel, because you have several hats on. You're working for Siemens and Erlangen, Germany. With this, you represent one of our most important customers. Siemens is, as anyone knows here, I think one of the leading companies in the field of industrial automation, and therefore having its own demands on digital standards, of course. On the other hand, Siemens is a producer of company software such as PLM systems or requirement management systems, which in turn define via their data models how information from standards is processed and made available in the customer process. Furthermore, Ralf is a very active supporter of our national initiative Digital Standard that we are doing together with DKE in Germany. He is the IEC VP and chairman of the Standardization Management Board, SMB. And since 2021, he's co-convener of IEC Strategic Group 12 on digital transformation. In the following, Ralf will give us an overview of Siemens' digitalization strategy, and he will show how the topic of smart standards is being addressed and handled at IEC. Thank you, Ralf. Go ahead, please.
Can you hear me well?
Yes.
Okay, thank you very much, Sebastian, for giving me the chance to talk a little bit about digital transformation in Siemens, which is the first part of my presentation, and then what I think are the consequences also for the digital transformation of standardization, and I deliberately call it standardization, and not only standards because that's only the product, but it will have more severe consequences. But before I start, I must say I have really enjoyed the previous presentation, especially also coming from John, because it's a completely new area for me. And I'm kind of relieved that John hasn't shown a completely 3D printed F-35 fighter jet yet. And I hope this is going to take some more time before we have that. So anyway, let me come back to Siemens, and please show the next slide. So thank you very much. Those of you might not know Siemens. Siemens is an electrotechnology company which has been around for quite some while. And also going back to my previous speaker, I must say usually I'm representing the oldest company in the panel, which is not the case today because John Deere is older and the US Navy, of course, too. So we are active in a number of areas. We have been splitting our activities into several separate companies. And you see the white ones down there are the separate companies, Healthineers and Siemens Energy. These are traditional Siemens companies which look into, on the one hand, healthcare systems, and on the other hand, into the whole area of climate change, CO2 emissions, decarbonizations. Traditionally, we have been very strong in fossil power plants, but this is moving away to the more regenerative forms like wind and hydrogen. And also Siemens Healthineers, and also, of course, also the management of the overall energy system, which comes back to digitalization in a perfect way. On the Healthineers side, we're looking into personalized healthcare, and that's also a very close connection to digitalization and applying digital methods. Now, the core of Siemens today is really around industry, infrastructure, and mobility. And as Sebastian already said, we are a world leader specifically also in industry automation. That will be the core of what I'm talking about. So next slide. We haven't been around when the steam engine was actually invented, which was 700s, around 700. But since 1847, 10 years after John Deere, we have been around, and we have been very active in everything which is connected with electricity. And that's what we called the electrification, not only of industry, but the whole society. Started at that time, around about 150 years ago. And since then, we have seen a number of disruptions, which we call Industry 3.0, which is the last century's uptake of electronics and IT, which had a huge impact on the automation of the production. And then the latest since the last 10 years, maybe, which is kind of summarized under the term digitalization, is really the merging of the real world with the physical, with the cyber world and the digital world. So that's where we live here, and Siemens has been active in that field for around about also 10 years, I would say. Next slide. So this shows a little bit some of the technologies and some of the things we are really looking into when we talk about a digital enterprise. And unfortunately, I cannot really talk about all of them, and each of them is a very interesting topic, like how we can implement digital workers with the help of augmented and virtual reality, how we can use AI and data analytics to make really sense of the huge pool of data that we are actually collecting from our installations and also from our users and so on and so forth. And certainly there's a lot to be said about plug and produce and everything that's around this kind of component, this optimization and a more flexible production system of the future. I will focus a little bit on the topic of digital twin, because I think that is my connection to the standardization world that I would like to make today. And what that means is basically that we are putting everything that we have from our products when it comes to the manufacturing, the operation, the maintenance, and everything. All this data is put together and is made available to our tools and the engineering systems through means of a digital twin. And this digital twin is not restricted to the data that we as a company own, but it is also necessarily including data that comes from our supplier and also data that comes from our user. And that has huge effects on the way we can actually, we are looking at business models. And I'm going to try to tell you what Siemens has done in the last years and what was the result of where we are today, and then make a connection to what I think is the consequence also for standardization organizations. Next slide, please. So this slide shows that we are talking today about a digital enterprise when we are talking to our customers, whether they come from process industry or discrete industries like the automotive area, or the process industries like, well, chemical plants, also what we've heard earlier, also when it comes to farms and everything where you produce and kind of deal with certain substances. Now, the core of all that is that we have a digitalization of the field level, and that we can actually get the data from the field level into our systems in a meaningful way. And that has been done for quite some time using industrial communication. But today, this is much more fluent and flexible, because we are now working on identifying sensors in the field or any field device which kind of can use plug and connect, and they will readily provide all the data that they have in different phases of the production process. One precondition is, of course, industrial security. We need to secure all the data that we are collecting. And there are many, many examples where this didn't work. A very infamous Siemens example is Stuxnet. And since then, of course, a huge part of our activities around securing the integrity and protect the data of ourselves, but also of our clients. And one new thing here is really what we call industrial services. And that's kind of the front end to our customers today. So we are not really trying to sell them products. We are not trying to sell them specific tools. We're trying to sell them services. And that makes quite a difference. So next slide, please. This is the situation from 10, 15 years ago, and it has been around since this famous Industry 3.0, where you have the field devices and the controllers and the communication, which provide you with a huge set of data, which is used by specific tools to do a certain job. And you can see this job spans the whole life cycle of the plant, but also of the product, from design to the manufacturing, to the operation, maintenance, and the decommissioning. The problem is that first of all, there was not enough level of standardization when it comes to the data. And secondly, of course, the problem here is that you are collecting data for specific purposes. And that means it's very difficult to really look at all parts of the life cycle and really come to an integrated workflow. There were huge gaps between the data coming from an engineering system to the automation system, between simulation and automation, between 3D visualization and maintenance, and so on and so forth. And you were losing a lot of time and money in transferring some data from one application to the other. And that obviously makes it very, very difficult to turn the data that you have, not only from the field devices, but also from all your tools into meaningful information. So that's a picture of yesterday. And the next one shows how we are doing this today. And this really makes use of all those technologies around IoT, edge, and so on and so forth. And today, basically, we are collecting data from all different kinds of domains, from all different kinds of the life cycle. And we are putting it together into one platform. And on top of that platform and on top of all that data, we are developing new applications which can basically make use of all the different parts, the different life cycles, the different applications, and the different OT devices in the field. And so this is how we do it today. Basically, we are producing a huge data lake. And on top of that data lake, we are then providing services. Some of the services are still the same that we have provided 15 years ago with engineering, simulation, 3D visualization. But we also have the opportunity to come up with new applications and services which span not only, or which encompass not only one specific silo, but also use the data from others. So that's where we are today. And please, next click. And that also, as I already indicated, kind of changed the way we are operating with our suppliers, with our partners, and with our end users. Because obviously, it is not enough that Siemens has access to its own data in own installations. We also need access to the supplier data. We also need the access to our competitors' data that is exposed through field devices in order to utilize that in the applications that we are providing to the end user. Also for the user, we give them the chance to develop their own services and applications on top of the data that we provide. And that's a big difference because it means that we are not trying to guess the next killer application. We are really giving access to our customers to make optimal use of what we provide to them. And that's a kind of a paradigm change, I must say. And that's behind this nice term of customer code generation and stuff and so on. And our CTO, Peter Körte, he has made it very clear. He said, well, today, the main requirement is that we can have access to the data. We need the data available in a format that we can give this to our customers so that they can find the best way to make use of that data. And there are several examples also of some services developed by users, which nobody thought about when we started this whole project and this approach. So that's a very important part to understand. This really changes the business model and your relation to your customers and to your suppliers. And the competitors, of course, too. So let's go to the next slide, in which I will come back a little bit to the data acquisition part of the picture. In many ways, in the industrial environment, we are following a principle which was laid down by an initiative which started in Germany, which is called Industry 4.0, and which introduced the concept of an administration shell. And this administration shell is really kind of the plug and play component in how we access data and connect with different systems. You need to understand that for all those different domains and devices down there, it's not like we are doing that on the green field. There are lots of protocols out there which are established, a lot of repositories which already give you access to data, but for a specific domain, for a specific product, for a specific part of the things you need to use in your overall picture. And it's absolutely clear that we will not change that. There's not going to be the world digital twin. There's going to be something which is able to connect to different repositories, different protocols, in different ways to access data from different technical areas and domains. So what this little picture on the right-hand side shows basically is the administration shell is really providing a kind of an interface to different kinds of repositories in explaining to me as the IoT platform operator how and what kind of data I can get from this device. So that's really important to understand. And that's a little bit how we approach these things in a general way. Next slide. Please click once more. So a little bit more detail. This administration shell, which is kind of a metadata describing what is below in this model in the asset, really can include a number of submodels, a number of different protocols, a number of different descriptions. And today we are quite well advanced when it comes to the mechanical description or the electrical description of a certain asset. We are starting to model the functions and capabilities of the asset in order to utilize what I can get from the asset. Next click, please. But there are new submodels possible. For example, submodels around sustainability, which include information about greenhouse gas emissions, the carbon footprint of your product, and so on and so forth. And this is currently ongoing. And we already talked about the huge regulatory push that we currently see to make this data available. So next slide. This shows an initiative of the German Electrotechnical Association, SITVI, in which we try to really have a very good understanding of the carbon footprint of a control cabinet. And interestingly enough, if you try to assess that, you find out that less than 10% of the footprint comes from your own activities. More than 90% of the activities of the footprint and the greenhouse gas emissions come from your suppliers, the ready-made parts you use, and the usage of your product. And of course, this is a huge topic for standardization because we need to use equivalent models and methodologies and equations to come to these numbers. But what I want to show with this slide is it also includes the necessity to have access to this kind of data in a digital format so that every manufacturer and everyone can use that data based on the same international, hopefully international standards, and that we make that an integral part of the overall data collection of our products and solutions and applications. Next slide. So to summarize where we stand today, we at Siemens are using a very data-centric approach in which we try to get all the data that we can get, regardless of what kind of protocols, format, and so on they use, as long as we know what kind of framework, what kind of description, what kind of semantic description of this data is kind of the base of this kind of description, because then we can put it together in our overall data lake, so to speak, and build applications on top. And this is clear that we are not talking about the one world digital twin. There are digital twins for the product, there are digital twins for the performance, and so on and so forth. So there are different parts, but the important thing is that we make them interoperable. So next slide, next click, please. I've already shown this, and now I come to the part on the standards part. And next click, please. And obviously, what we would like to see is that standards are an integral part of this overall digital pictures, which means that I would like standards in a form that describe requirements, test specification, and other important parts of the standard in a format that I can describe as a submodel or as part of my overall digital twin. Next click. And that's why, for example, we really like the activities that are currently ongoing on the CENELEC level on the future of standards, specifically the pilot number 5 on standard information model. And this standard information model really, or this picture, which is taken from this pilot, already shows that standards, the information about standards is provided in a way that I can access it as I can access other repositories and other semantic descriptions, whether they are mechanical, electrical, functional, and so on and so forth, and make them an integral part of my asset description, which in turn then can be used to produce new services. The next slide is a little bit showing a different perspective, and that's just a kind of an experience from my company background. We are actually at Siemens, we are increasing the number of software engineers that are working for Siemens. And increasingly, those younger generation and this type of people, they like to work in environments which have an instant feedback cycle of things they are currently working on. So it is relatively hard for us to motivate Siemens employees to participate in standardization. We are not bad at that. We are still at a huge number, but it is relatively easy to motivate at least the younger generation to actually participate in open source and Plugfest and these kinds of things. So I never heard a problem from a manager saying you can't go to an open source event. We always have to argue about the standardization. So I think we need to change something, and the next slide kind of summarizes what we think needs to change in standardization. I think, and I don't want to overburden the speed, but I talked about we cannot wait 3 years for the revision. And with this, I mean we need to increase the flexibility to really use parts of the standard, update parts of the standards much faster. We need to increase the quality. We already had this discussion about the liability. What happens if a machine, a software package, readily uses the code component out of a standard? And this has been wrong. That's a big issue. And obviously, we are also thinking we need a new work environment. And on top, we need security that's clear. So that's a little bit in a nutshell what we think we should change standardization. And the last 2 slides come back to my activities, as already mentioned by Sebastian, which are on the German level when it comes to EDIS and the activity of DIN-DKE, but which are also focused on the IEC. And there we have introduced a smart standards concept, which we think includes all those elements that would really enable us to meet our requirements by cutting standards into fragments, which we call information units, restoring the context and classification information that is currently contained in the document, through attaching to those information units a kind of a functionality or capability, which in turn enables us to really represent this data or this information in terms of a software executable code. And that for us would really be the core to build up a real API portal. And I'm sorry that this calls IEC, because that's surely something we need to do together with ISO. And there are several meetings already scheduled to further discuss that. My last slide now shows, please, in the next click, where we stand currently with the discussions in this strategic group 12 that Sebastian mentioned. And I don't want to explain it. I just want to mention that together with Joe and Damien and Ivan, we have put together a short list out of 125 use cases collected by CENELEC and group them into what we call a business use case or generic use case. And you see the number of 12 there, which come with terms like I must be able to reference, I need to get notifications, I need to be able to search, I need the change record, something we heard earlier in some of those earlier presentations, and so on and so forth. And I think at that level, this is really something that I think is something where we can start a collaboration between the different initiatives and really also collaborate with the user, because this is a user story. It represents the needs of us users. And one last thing, because I see the time clicking down here, I must say, looking at the 12 here, and I think the same impression was with Joe and with Ivan and Damien and Sebastian. To me, this is not really surprising. It is something, looking at that, I said, well, that comes natural. There's nothing in there that really comes to my mind that I said I wouldn't have expected. And that's why I say, we need to understand that in a digital transformation, you need to provide the data in a digital way and then give it to your user so that he or she can play with it and come up with services that you cannot identify upfront. Because this is like Henry Ford. If I would have asked the people what they wanted, they would have told me they want a better horse or a faster horse. They would never ask me whether they can get a car. So I think that is what we need to keep in mind when we talk about this. And thank you very much for your attention.
Thank you, Ralf. Thank you very much. Great presentation, really interesting. We have a few comments. First of all, there's one statement. I think you addressed this a little bit with the asset administration shell and the question how to map to different partial models, but I will tell the statement though from Daniel Prentice, saying there is a need for standardized data as a foundational enabler for the enhancing capabilities you showed, such as the digital twin. There seems to be a lack of discussion on reference data definition across our industry and the need for unification of and adherence to data standards.
I would say we will never be situation where we will have all the data from all the different domains in the same kind of format or things. The question is, what kind of necessary preconditions do I have on repositories, on data representation, so that I can make sense of the data coming from industry, coming from buildings, coming from transport and so on. So what kind of general rules do I need to follow in order to be able to produce semantic interoperability? And this discussion is actually a discussion of the standardization community, because we already have committees in JDC1 which are talking about exactly those preconditions to merge different kinds of repositories and data sources.
Yeah. I think there's one thing that sometimes hits me when we discuss about smart standards. I think that the level of understanding that we have, or the understanding of smart standards, still is quite different across different organizations. Some of the things and the elements that you just presented are clearly not level 3 smart standards. Without going into the details, what do we understand exactly under level 3 smart standards? No, but if we say that level 3 smart standards has requirements tagged as a sentence in order to make them usable in requirement management system, this is something easy to understand. Whereas some of the concepts that you just explained are going deeper in towards a higher degree of fragmentation of content and perhaps level 4. I think this is something which is obvious for you. I think it's not obvious for the whole community, but it's a very relevant question for the next panel, for example, when we talk about business models and what will come when. And what I really like about the generic use cases you mentioned at the end is that this provides some easy to understand and clear categories. And by reading the name of the category, you don't know everything that's in. But looking inside the category, you will see concrete user stories, giving an example what the category of search capability, for example, is about. And I think this could guide us as a reference when talking about the use cases that we just heard from the speakers talking prior to you. There are certain use cases that can be categorized in these generic functions. I think this is something where we could perhaps meet and exchange a little bit more on this common ground and try to understand what Peter, for example, explained us from John Deere, what his use cases are, and trying to see how they match in these categories. There's one question regarding the competencies. What do you think? What competencies we need or are needed in order to create these kind of standards that you just mentioned? Of course.
Well, this I think for me is like the equivalent to a chemical reaction. You first need some activation level to get people above the energy threshold, and later on, hopefully this will go down. So what I'm trying to say with that, I think we need to put in place tools like online authoring, which gives the tools to the experts how to write the standard in a certain way. But hopefully he or she will never have to understand the machinery behind. So what we are talking about here is the machinery behind, how to make references, how to make connections and stuff. So in my hope is that in future standard experts will do the same as like in a low coding environment where you don't really understand the programming language, but you can still use bits and pieces as templates in order to produce something which is semantically much enriched towards what we have today. Yeah.
But there again, it will be an evolution, because what we need for level 3 smart standards is obviously not the same as what we will need for level 4 in a far future, let's say, right?
Absolutely.
Okay.
It's certainly on the level. And even in Siemens, my guess would be that today most of the usage is level 1 or 2. There is maybe like 15 to 20% of usage of level 3. And there's basically no usage of level 4 today.
Yeah, yes, of course. Anyhow, this will be a joint voyage, because of course you have to train, or you have to ensure that the expert that you send to the standardization groups are skilled, as well as we have to make sure that the committee management is able to take this information, moderate the consensus, but also take and transform this information according to the information model that we have defined. So it's kind of a joint challenge that we face, the standards organizations and companies using the standards. Good. I think there are no further questions. I think we are quite good on timing. Jimmy was there and then disappeared. Lakshmi, could you help me? Are we good on timing?
Yes.
Do we wrap it up?
We are ready to go to break. I just want to add that if there are any, there were quite a few questions for this panel, and we have documented the questions. So those that went unanswered, I think, Sebastian, you did a great job of covering most of them. There were a few that were unanswered that we will follow up with the speakers and then get back to those who asked the questions so that they have their answers. So why don't we go to a quick break? And if we can come back at 11:35 Eastern time, that would be great. And then we will get ready to hear from the business folks to see how we might incorporate these ideas into a business model. So thank you very much. We'll see you soon.
Thank you very much. Thank you to all the presenters. Great,
thank you.